Hey everyone, welcome back to The Explainer. Go ahead and grab your coffee and let's put on our senior engineer hats, because today we are doing a deep dive technical review of a massive drop from Google. We aren't just looking at a few shiny new features here. We are evaluating a fundamentally new developer infrastructure that Google has quietly deployed. If you build software, if you manage engineering teams, or honestly, if you just want to know where the absolute bleeding edge of technology sits right now, you need to pay close attention to this breakdown. I want to start off by posing a pretty heavy question directly to you. Is your current development stack already obsolete? Because guys, the stakes here have completely changed. We're shifting from a world where AI was just a coding assistant, a helpful autocomplete sitting inside your editor, to a fully autonomous agentic platform that literally does the driving for you. The infrastructure we're about to unpack treats you less like a heads-down programmer and much more like a high-level manager of digital workers. So, here is our agenda. Basically, our request for comment for this explainer. 1. The core engine. 2. Anti-gravity workflows. 3. Real-world automation. And finally, 4. The verdict. Okay, let's dive into this. Section 1. The core engine, powered by Gemini 3.5 Flash. Now, to really grasp this new infrastructure, you can't just view Gemini 3.5 Flash as another language model. It is the raw underlying compute engine for the whole system. And the absolutely critical metric here, a 4x multiplier in output tokens per second compared to other frontier models. So why does token speed matter so much? Well, when you're running parallel agent workflows, where you have multiple AI agents talking back and forth and executing tasks all at the same time, latency is your biggest enemy. If the engine is slow, the whole orchestration bottlenecks. This 4x speed multiplier is the key that actually unlocks real-time autonomous coding. But hey, speed is only half the equation, right? Check out these numbers. Gemini 3.5 Flash operates at roughly a third to a half of the cost of their previous flagship, Gemini 3.1 Pro. For engineering managers and developers, the immediate ROI here is just undeniable. When you combine 4 times the speed with a massive reduction in operational cost, it makes 3.5 Flash the absolute new default for builders everywhere. All right, moving to Section 2, Agent Architecture, specifically Anti-Gravity 2.0. So that powerful compute engine needs an interface, right? And that interface is Anti-Gravity 2.0. This is a desktop application built specifically around running multiple AI agents in parallel. Think about your classic IDE for a second. You've got your file explorer, your raw code lines, your cluttered terminal window, that place where we've all spent way too many hours trying to manually center a CSS div. Well, Google literally stripped all of that away. The entire interface is now essentially a chat box. It actually looks a lot like WhatsApp. You aren't writing syntax anymore, you're coordinating multiple agents that are actively solving different pieces of the same problem at the exact same time. Let's walk through how this actually flows dynamically. In their testing, they used a super simple plain English prompt. Make a Chrome Dino Infinite Runner game that plays itself in a cyber theme. Boom. Within 4 seconds, the agent mapped out the entire architectural plan. Visuals, styling, movement logic, all of it. The absolute only manual step for the human was clicking a button that said allow one time to give the agent execution permission on the local machine. From there, it built the game, and when it hit an error, it autonomously investigated it. No human intervention required. So the crucial point is, does this actually work in practice? Let's get into Section 3, Proof of Concept with 3 automation tasks. We don't want to just read theoretical docs, we want to see it run in production. So here are 3 specific real-world automation tasks an engineer can execute today. First, autonomous game building and debugging. Second, seamless UI to code syncing using a brand new tool called Stitch. And third, massive database analysis using an agent routing bundle called Science Skills. Let's break these down one by one. Looking closer at task 1, let's jump back to that Cyberchrome Dino game. So when the game was first opened in Chrome, it initially threw an error and failed to load. The human dev simply typed back a message saying, "This is not working." That's it. The anti-gravity agent took over completely on its own. It tried multiple approaches until the game actually loaded. But then the AI player inside the game kept crashing into obstacles. Now, rather than you manually hunting down the bugs and tweaking the jump logic by hand, the agent noticed the failures without a single new command from the human. It investigated its own code and fixed the obstacle detection entirely by itself. A fully working, self-playing game with 0 manual code written. Incredible. For task 2, let's talk about UI. The old way of designing software was a pain, relying on siloed, static design mockups. You design it, then you throw it over the wall to the dev team. The new way? Google's Stitch. Stitch gives you this live streaming canvas where designs render in real time right as the AI generates them. You get HTML native motion to build actual working animations, not just pretty pictures. And the absolute best part? It syncs your entire codebase directly inside Stitch, giving you direct exports to platforms like Netlify and Bolt. If you want to change something, you literally just highlight a single button, tell the AI to edit it in place, and does it without regenerating the whole layout. It's the full loop in one seamless workflow. And for task 3, we're looking at raw data analysis. Google introduced a bundle called Science Skills. This connects the anti-gravity agent platform to over 30 major life science databases. By routing agents across this massive ocean of data, researchers were able to analyze rare genetic diseases linked to specific mutations. Guys, what historically took hours of manual querying and cross-referencing was completed autonomously in minutes. It's a real game changer for scale. All right, let's wrap this all up. Section 4, the engineering verdict. And this brilliantly illustrates the big picture. As we step back and assess what this shift means for the software development lifecycle, it all comes together perfectly. You have your compute layer running on the lightning-fast, highly cost-effective Gemini 3.5 flash. You have orchestration handled by Anti-Gravity 2.0. You've got full-loop UI over in Stitch and specialized agent analytics running through Science Skills. Make no mistake, this isn't just a disjointed collection of tools. It is a unified, fully deployed infrastructure stack. Now, to truly understand how permanent this industry shift is, just consider this exact quote from the source material. Google is spending $190 billion in CapEx this year to make sure it happens. Wow. Capital expenditure of that magnitude tells you literally everything you need to know. Google is not just building neat little features on the side. They are aggressively rewriting their entire ecosystem from the ground up, making sure AI is operating underneath every single surface. Which leaves us with this final, truly provocative thought. As these tools become the absolute industry standard, you have to ask yourself, are you writing code or are you managing agents? We are officially moving out of the copilot era, where AI just helps you type, and into an autopilot era, where AI builds and deploys while you simply steer the vision. So take this blueprint, apply it to your own workflows, and decide how your engineering teams are going to adapt today. Thanks so much for joining me on this explainer, and keep building.